So last time we started section 3.3 talking about subtraction of whole numbers, and we were just about to take a look at other base subtraction using some of the algorithms that we discussed last time. So if you remember, there were several algorithms. Let me just run through their names real quick. There's a concrete model, right? And so we talked about how that would look. The standard algorithm that you all know and love. The expanded algorithm, which looks like the standard algorithm, just a little bit more place value notation to it. Equals addition is the one that we ended with, and this one is the idea of not having to borrow to do subtraction or not having to regroup. And we do that by adding equal amounts to the I almost said numerator and denominator, that's not right at all, to the first and to the second value. So we're going to take a look at doing this with other bases. So in particular, we're going to start with base 8. And if you'll remember, base 8 has the digits from 0 to 7. So we're going to do subtraction of the numbers 3, 4, base 8, and 1, 7, base 8. And what I'd like to do first is I'd like to show you what it looks like with the standard algorithm. Okay? So in the standard algorithm, we start with the right-hand column, and we regroup if we don't have enough to subtract. And I can't subtract 7 from 4. So I do need to regroup. So in regrouping, what that would look like is it would look like taking the 3 and borrowing or regrouping one of those values into the other column. But this is base 8. So very much physically, I actually brought it today. I told you I'd remember it eventually. So these are base 10 blocks. So these have all the 10s, right? 10 by 10, this is a flat. This one's a long, okay? So, and then I've got the little units ones too, okay? So if this were base 8, what I would literally be doing is I would be borrowing 8 of these, because this long would be 8 long, and I'd be adding it to the 4 little individual ones that I already have. So I have these 4, I have 8 more. So if I were counting them up with our numbers, that would be how many? It would be how many? I have 4, and I borrowed and have 8 more. It'd be 12, right? So there'd be 12 of them. So I would actually have 12 right here. So, because I'm only borrowing 8, because I'm working in base 8. And then I would subtract, just like we would subtract if we had borrowed 10. Whatever that value is now, our value is 12. 12 minus 7 would be, don't overthink this, 5, thank you. And then 2 minus 1 would be 1. And this is base 8. Now, if I'm doing this with equal additions, then what I would want to do, because I think that's one that last time is a little bit new of a strategy for us, is my goal is to get as many zeros as I can sort of down in the second value, because zeros are easy to subtract. Now, what comes after 7 in base 8? 1, 0. It's 1 digit away, right? So if I add 1 here, equal additions, I add 1 on top. The top becomes 3, 5. But the bottom becomes a 1 in the 8's place, plus another 1, 0, right? So I end up with the number 2, 0. And here if I subtract, of course I get the same 1, 5 that I got in the previous algorithm, but I do it from a slightly different perspective. Okay, I'm so glad I brought my base blocks because I'm about to show you something super cool. You ready? Okay. These are base 3 blocks. Yeah, and I've got a base 3 problem. How wonderful is it that this worked out? I'm so excited. All right, so we have the number 1002 base 3. So this is 1 block. I have 0 flats, but this is what they look like. It's a 3 by 3 flat. I have 0 longs, but this is what it looks like. Okay? And then I have 2 of these little bitty unit guys. That's what I have. So if I'm doing this with regrouping, I have to regroup a lot. The first one's totally fine. I have no problem with 2 minus 0 is 2. Like, that's great. But the problem, of course, after that is that I need to borrow, or I need to regroup in order to get values to subtract my ones from. And I have to go clear over to the left-hand side in order to do that. So if I borrow, or if I regroup, this becomes 0. But what am I borrowing in base 3? How many? 3. Because I'm working with 3s, right? When we borrow in our base, or when we regroup in our base, we always borrow or we regroup 10. Well, we're regrouping in 3s because this is base 3. So it's like I'm physically taking this 3 long, or whatever shape it is, and I'm breaking it apart into individual pieces. So now I have 3 of these, plus this one had 0 to begin with, so that's not very exciting. But I would add it to whatever I had here. So there's 3 in that column now. Now that's fine for that column, but I can't actually still subtract in the 3's column itself. 3 squared column's good, but the 3's columns isn't. So I have to do the process again. Let me shift this down just a little bit to give myself a little more space. So right here, what I see is I need to take this 3 and make it a 2 and regroup again. We've already said in base 3 when we regroup or we borrow, we regroup 3, right? So this 0 here becomes a 3. And then again, we subtract. So now in the 3's column, that's this one right here, I can do 3 minus 1. That's a 2. And then in the 3 squareds column, I can do 2 minus 1. That's a 1. And this is base 3. Okay, so I'm going to send these around just so that you can kind of see them and take a look, because I've talked about them enough times. We should definitely do it. I'm going to do it this way, and then it'll
That's okay.
here.
Sorry.
Okay, but I'd like to show you again what this looks like with equal additions, because I think that's the most unique of the other ones that we've looked at in this particular section with subtraction. So on this one, if I have 1002 minus 110, again, I'm trying to get zeros across the bottom as much as I can, so that when I do my subtraction, I don't need to borrow. That's the goal. So the 2 minus 0 is fine. I already have a 0 in the ones place. But anytime inside of base 3, I need to add things to get to the number 3. So when I'm working in base 10, like on the problem up here, I kept adding values till I got 10, right? So the reason I added the 2 here was because 2 plus 8 is 10. That's why I did it. So over here, when I'm adding, I'm going to add a number to this one so that I get the number 3 when I get it. And so that number I would need to add is the number 2. But it's 2 with a 0 because it has to be in the right placeholder, right? It needs to be in the 3's place. So I add 2, 0. So if I do this, I get 1, 0, 2, 2. And I get a 0 is already here. But now when I add the 1 with this 2 and I get 3, I have to regroup into the next column, right? The whole reason I did it is so that I'd get a 0 and it would force me to group over into the next column. There's already a 1 in that column, so it goes up by 1 and it would be a 2. You don't get to stop there because you would still have a column that is bottom heavy, right? Now this column right here does not have the ability to be directly subtracted. So we have to do the process one more time. So what would I have to add to that 2 to make it a 3? Just a 1. And so it would be 1, 0, 0 to put it in the right column. And if I do it on bottom, I have to do it on top to the first value. So this number becomes 1122, or 1122. What's going to happen with 200 plus 100? Normally, what was it? Normally it would be 300, right? 1 plus 2 is 3. But I don't have 3's in base 3. It's going to be 1 with 3 zeros, right? So it will have to regroup into the 4th place over. But then I'm able to subtract without having to regroup. So again, I have the 122 base 3. Okay, so we're going to finish up this section with mental math. Any questions on either of those base addition, subtraction rather, problems before I do? Okay, so we're going to shift gears then. We're going to take a look at some mental math strategies for subtraction. Now, some of these feel a lot like the mental strategies we had for addition. That's okay. In fact, some of them even have the same names. This is one of them. Breaking up and bridging. So if you remember breaking up and bridging with addition, what it meant is it meant taking the second term and breaking it apart. So 38's 30 and 8. And what you do is you take that 46 and you subtract the tens value, the biggest one, the 30. So it's 46 minus 30. 16. And then you subtract the ones digit. So 16 minus 8 is 8, right? Yeah. Okay, good. Yeah, it's 8. Okay, so the idea is that by subtracting the tens digit first, which you'll be able to do because the first number is bigger than the second one. So by subtracting the tens digit first, the number becomes much smaller and easier to work with. We're more familiar with the number 16 simply because it's smaller. Okay? Sometimes it might be small enough that it's actually on an addition or subtraction card that the child's already learned even, right? So I'm to the number 16, which is a much more familiar number. And while in theory, 46 minus 8 is not really any different than 16 minus 8, it kind of is. Because 16 minus 8 is one of those basic facts that kids are much more likely to know than 46 minus 8, if we were sort of doing this in the other order. So yeah, we can do the 16 minus 8. This is breaking up and bridging. Trading off. Trading off is actually just really equal additions. So if you think of 46 minus 38, again, your goal is no borrowing. So on the second number, you would try to get zeros. What would I have to add to 38 to get it to have a 0 in the ones place? 2. And if I add it to 38, I add it to 46. So I have 48 now, and 40. And 48 minus 40 is 8. And the last strategy is called drop the zeros. So again, this doesn't work on every value, but when it does work, it's a nice one. This is 4,600 minus 3,400. So what that really means is I'm essentially looking at 46 minus 34. I'm ignoring or dropping the zeros. So what do I get when I do 6 minus 4? 2, and 4 minus 3? 1. And then in my answer, I put the zeros back on. 1,200. Any questions on that? Yeah.
Are we ever going to have to do the mental problems and strategies with other base points for subtraction?
No. I don't think your book asks any. In fact, I'm almost sure they don't. So, yeah. No, we won't do mental strategies with other bases.